parallelogram. Now the first thing that's important is when you're looking at a shape, do you recognize it as a parallelogram? Now let's talk about why this qualifies as being a parallelogram and not, say, a trapezoid. All right, the first thing you need to understand is that we have, see this line that I have highlighted here in red? Over here we have another line that's parallel to it. So this and this are parallel to each other. Now if we look at this line here, that's parallel to this line. So opposite sides are parallel, and then the other thing that's helpful to know is that the opposite sides are congruent. See, this is the same length as that. This line right here is the same length as that. All right, the next thing to understand is when we talk about area, by the way, parallelogram, make sure it's a four-sided, it's a quadrilateral, four-sided shape. I just wanted to throw that in there. All right, when we're talking about area, we're talking about how many square units do we need to fill the object up. So just visually you can see so far I have 3, 4, and you can see that I can fit more in there. Now if we kind of ballpark this for an estimate, I'm just going to move these out of the way, you can see that we have ones that are complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that almost makes 10. This makes 10 for sure. This is almost 10. But I want to point out something else. See this piece that's not part of it? If we were to talk about one square unit, I'm just going to drag this over to help you understand. See how that blue little triangle represents the piece that we don't have? But do you see how we kind of make up for it over here? This is a piece that we do have. So if we take this piece and add it in with the piece that got cut off here, do you see how that represents one whole square? Because I used to be confused about why the formula is the same for a parallelogram as it is for a rectangle, and even for, we can even use it for a square. So let's just figure out the base and explore this, shall we? So if we count how many units long the base is, 1, 2, 3, 4, 5, and let's say 5.5. So the base, 5.5. Area equals 5.5 times the height. All right, now the height, this line does not represent the height, and the reason why is because it's not perpendicular to the base. The height has to be perpendicular to the base. That means it forms a 90-degree angle. Now on a worksheet, what they're typically going to do is they'll put like a little symbol. They might put like a little line like that. That's the perpendicular symbol. And it may be even on the outside of the shape. But you see in this case, the height of this is 1, 2, 3. 3 units. All right, so to find the area of this, we have to multiply 5 and 5/10. Whoops. See if we can clean that up a little bit. That doesn't look like a 5, does it? Let's try again. I wish the pen worked as well when I'm doing a screencast as it does when I'm not. 5 and 5/10 times 3. All right, and then obviously here we get the 15. Here we get 15 plus the one more, 16. And then we have to remember we have to go over one position and over one position. The area of this is 16 and 5/10 square. Let's say each one of these yellow boxes represents a square centimeter, so let's just pretend that it does. So in other words, if you were to figure out how many of these guys you need to fill up the whole shape, it would be 16.5 of these things. Right? Hopefully you understand a little bit more about area of parallelograms.